In this next module, we're going to cover bisection. I've long called bisection a superpower because of its ability to quickly isolate the source of a regression in the web platform. Once we have the source of the regression, it is often very simple to get it fixed. Bisection works on one of the simplest concepts in computer science, that is, a binary search. We find a build where the problem exists and a build where the problem didn't exist. And then we successively divide the builds between those two builds to find in which build, and more specifically, in which commit, was the regression added to the codebase. Given this information, it is then relatively easy to fix the bug, or in some cases, we find that it was an intentional change, and the website or the application needs to change instead. Let's take a look at how this works. We have this case that was reported to our support where you'll notice that this emoji loses its color in version 97 of the browser, but is properly colored in version 95 of the browser. How does this happen? Well, fortunately, the repro was super simple. We have a repro page that causes this problem to occur. What we're going to do is we're going to use the bisect script to perform this bisection. The arguments to the script are relatively simple. We say which version of the platform we're trying to debug, in this case, Windows, which version was bad, version 97, which version was good, 95. We pass verify range to tell the system we want to make sure that those two endpoints are correct. We tell it to use a local cache for faster performance, and we don't want any kind of first run dialog in the browser. And then finally, we provide the URL, in this case it's a file path, of a page that demonstrates the problem. Hit enter. The Python script downloads a build from Chromium's continuous build archive. So this is an archive of builds that were made over the course of the development milestone. This isn't limited to the released versions. They have, in Chromium's version of this, they basically cut new builds every 10 or 15 changes. So, okay, we've got our first one. So this is version 95, and you can see that the checkbox is correctly filled. So we're going to close that. We're going to grade this. We're going to say, hey, that build was good. Now, in the background, it had already downloaded the next build that it wanted to try. And in this case, we're expecting it to be the bad build. This is version 97. And indeed, we lost our color. So we're going to close it, and we're going to grade it and say that this build was bad. Now, a build between the two, ideally approximately halfway between the two, is tried. And we see in this build, it's bad as well. So we say B. Now, the amazing power here comes from the fact that in Chromium's history, there are hundreds of thousands of commits. But because of binary searching, we're able to only evaluate about 12 builds to find the source of any regression. Take a look here. And in this one, it's good. It's colored again. So we're going to say that that's a good build. Each time, we're narrowing the search space by half. As you can see, the download there was fast because while we were grading the old build, it was already downloading the next build to try. And in this one, it's good. Now, this process is a little bit tedious, but if you have a simple repro, particularly if you've created a good reduced repro where you don't have to navigate around, log into websites, click, 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 it's actually not too bad. Even if you do actually have to perform complicated repro steps like logging in and so forth, let me tell you, this is infinitely better than what we used to have. Toward the end of Windows 10 development, I ended up spending 3 days trying to bisect a problem in the web platform. And that's because in the old days, to get new versions of IE on the box, you very often had to install a different build of Windows. And this build's good. As you can see, the revision numbers are moving around. And so we are tightening this range. We're saying, hey, we used to have a pretty broad range between two major versions, and now our range is getting smaller and smaller. This one's good. As you can see, we're now down to about 400 changes that we're bisecting against. we can see that this build is bad. The range is now down to just 100 changes. And this one is good. And this one is also good. One key reason to make this investment of your time is that bugs that have a bisection filed in them, particularly an upstream web platform bug, get much more rapid attention. You can file a bug in the Chromium bug database that gets ignored for years, unfortunately. But if you have a bisection and the note that it's a regression, very often someone will look into that bug within one day. This build's good. This build is also good. Okay, we've concluded the bisect. Now, unfortunately, we don't have per revision bisect. The folks who work at Google have a private share that have every built version of Chrome, but we're limited to the public built versions of Chrome, which, as I mentioned before, is usually 10 to 15, every 10 to 15 changes go into a given build that's in the public list. And so now we've reduced the size of our regression range from 2 major versions down to, we know that build that had the commit number 928114 was good, and the one that had 928122 was bad. So now we have a very short list of commits that represent when this regression went into the code base. So we open up our browser, we paste in our URL, and we'll get to see the upstream list of commits that went in, and one of these is the cause of the regression. Now, there's a bit of a science in figuring out which change caused the bug. In this case, tap back button. That doesn't sound like it's related. Reland, introduce a build flag for font manager to suppress undesired simulations. Well, that sounds a little bit interesting. We were looking at the rendering of an emoji. An emoji is a kind of a font, so maybe that's related. We have a revert, which means to undo a change. That doesn't sound relevant. We have a disable a web test, definitely not relevant. Changes to web tests don't change the behavior of the browser. A field trial for accuracy tips, that doesn't sound right. We rolled Perfetto. So a roll is basically when third-party code is updated. I don't know what Perfetto is necessarily. If you click and investigate, you'll find out that it's a tracing framework. So probably not relevant to a web platform change. We have open input device using libinput. That doesn't seem relevant. And cancel bar height animation. So that's definitely not it. So within this range, only one of these issues seems fairly suspect. So let's go take a look at that. We look at the change. We see that there's a bunch of housekeeping stuff. Let's read about what it is. So it says, we execute font matching loops with the intent to drop style, bold, and italic requests so that direct write does not return undesired simulations. Now, I'm not a font expert, and honestly, almost none of this stuff makes sense to me. But given that this is the only change within the range that seems remotely related, it's a pretty good bet that it's the root cause. And in fact, if we go back and look at what happened with the issue, it turns out to be exactly the issue. The fact that we're using bold in an emoji causes a problem with the way that the system asks the emoji to be painted. And so that's the root cause. And so you'll see that basically the bug was confirmed almost immediately, and then they had to figure out, okay, well, what are we going to do to fix it? And the fix turned out to be a little bit complicated, but ultimately it was made. And you can see that in the latest version, it's now fixed. So bisection is truly a superpower. And it's very useful for anything that reproduces in the web content area of Chrome and Edge. We have the ability to bisect against Edge itself, rather than bisecting against upstream Chromium. But unfortunately, this requires a bit more setup on your machine and doesn't work necessarily quite as simply as bisecting against upstream. And so in almost every case, I simply bisect against upstream, rather than going through the effort of trying to bisect against Edge. In some cases, bisection doesn't return a clear result. We'll get into why that is later, but it's worth noting that it can happen, and even doing a failed bisect, determining, hey, I can't seem to reproduce this problem, or I always reproduce this problem, is great information that allows us to root cause what might be causing the issue. I wrote a blog post about bisecting and a real-world example, much like this one. And the key thing is, you don't actually have to enlist in Chrome to do this. All you have to do is download the script and have Python on your machine. Take advantage of this superpower.